So this is where we switch over and we try and do the live example. So what I'm going to do, I have this one called electricity. And what I'm going to do is put this over here, and hopefully, as a room, we're going to build a system map of electricity and how it works to some level of understanding and granularity. I figured I'd pick something that everyone had probably had some experience with, and with a variety of different levels of experience in the room. So that's probably illegible, but that's not really important. What's important is what's going to happen over here. So who knows something about, let's start with the lights in the room. And we'll put in a node which represents the lights in the room. So we'll go down until we find maybe some hardware. I can't believe I don't have hardware. All right. Let's put in some. And by the way, the GitHub repo for this will be available afterwards. I'll push all the changes up. Box 3D, and it can be yellow. All right, so let's have lights. Boom, lights, there they are. So, how do the lights work? What do the lights need to work? Someone? Electrons, okay. So, you know what, I'm just going to chuck in electrons here, and I'm going to say that the lights depend on the electrons. Okay, so now there's a dependency relationship between the lights and the electrons. One of the hacks that I've used in the system that I'm using here, which is called GraphViz, for those of you who are either nerdy enough or old enough to remember it, is I have a default shape and color for the nodes that haven't been assigned to any class of things. Makes them stand out really obviously. It's like, oh, I don't know what that is. I better go and find somewhere to put it. So we're going to put the electrons into, let's put the electrons in the monoliths. We don't understand what they are exactly. So lights depend on electrons. How do the electrons get to the lights? Wiring. Great, let's have some wiring. Okay, so lights, wiring, lights also depend on wiring. Okay, wonderful. So there's wiring that comes out of the lights. A switch, yes, I like that. Okay, let's have a switch. Okay, lights depend on electrons and wiring. Now, we can have a conversation about how to represent this, right? Because does the wiring depend on the switch, or do the lights depend on the switch independent of the wiring? If you had just a switch and lights, they wouldn't work, would they? Electrons wouldn't flow. So, do the lights depend on the switch, depends on the wiring?
We need a user to switch the switch on.
We need a user to switch the switch on. Excellent. So, classes of humans are light seers, people who see lights. Okay, so the light seers depend on, they depend on the light to see, lights, to see what's going on. See, I misspelled it when the colour was different. So the light seers depend on the lights. They don't depend on the wiring, but they do depend on the switch, because you can't turn the lights on without the switch.
Do they depend on the switch, or do they operate the switch?
Right, I like that. They do operate the switch, but that's... And this is where you can get into conversations about granularity and what you're actually trying to represent, okay? So if this were a process flow, yes, it would definitely be an operate. But in this case, I'm thinking more of a dependency map. Okay? Does the switch depend on the lights? Would the switch work if the lights weren't there?
No, they won't work unless someone presses the switch.
Oh, right, that the switch depends on the user.
Yeah.
I like that. Yeah, good point. Oops. The switch depends on the light seers to work. All right, so now, I don't know if you can see, that arrow has gone back the other way. So the switch depends on the light seers to work. What about those electrons? Where do those electrons come from?
Switch needs a generator or the mains.
Is a generator or the mains, right? We could have either of those, couldn't we? So let's have a generator and mains. So the switch depends on, the electrons depend on the generator and the mains, don't they? Actually, the electrons depend on the wiring to get places. And they also depend on a generator or the mains. Okay, starting to get a little bit more complicated. Let's zoom out a bit. There we go. All right. Let's explore this generator thing a little bit. What do generators depend on? Let's pretend we're talking about like a little one here. Fuel. All right. Let's have a different shape of thing. No. All right. Fuel. Fuel is in there, and the generator depends on fuel. All right. What about this mains? What does the mains depend on?
Power station.
A power station. Sorry?
Dirty coal.
Dirty coal. Well, hang on.
Power station.
There's a power station, but there could be, transmission lines. So the electrons depend on the transmission lines, which depend on a power station. And I haven't put in transmission lines yet, so transmission lines, that goes in there. Okay. Power station could depend on operators. Now, operators aren't us, are we? Is anyone here qualified to operate a power station? I'm just asking for later. No? Okay. I'm going to have to rewrite that bit then. So, third parties, let's have operators. So, we've got operators now. Different colour. Those are external entities outside of our sphere of control. We can control ourselves. We can turn the lights off and on. There's some hardware in the middle there, but those are external humans or external organisations that we rely on. How about when we don't pay the electricity bill? There's a bill in there, right? Okay, so there's the documents. There we go. Electricity bill. Helps if I spell it right. There we go. We have an electricity bill as well, and the light seers. Do we depend on the electricity bill, or does it depend on us? It's kind of a bi-directional relationship, right? If we don't pay it, we don't get any light. But if we don't pay it, then the electricity bill doesn't get paid either. So we can make that be a bi-directional. So let's have the transmission lines depending on the electricity bill as well. Well, is it the lines or is it that thing that we've called mains?
Well, mains depends on the transmission.
Mains depends on the transmission lines. The transmission lines would still,
Transmission lines
Is that
go
the
to the
provider?
a provider. So like a retailer? Do you mean a retailer or a generator? They're both of them, yeah. Great. So we've got operators, we have a retailer and a distributor, yeah. Okay, we'll put those in. So your power station depends on the the distributor. No, the distributor depends on the power station. And the retailer depends on the distributor, and the electricity bill. This is a bad example for me to have chosen because I don't appear to be able to spell electricity reliably. So we've got a bunch of stuff that's shown up here. And it's not necessarily right, but at least it's a first cut at mapping a system of electricity and lights and light switches and how stuff might work. And we could zoom into individual nodes. We can group and cluster things, and we can explore the relationships and the dependencies, and we can introduce other kinds of relationships into it as well if we want. It's up to us as we go. But as a sort of an interactive worked example, hoping that gives you a little bit of the flavour. So if I were to now take this and print this out and stick it on the whiteboard, pen that said this is probably wrong, please update it, based on the level of cleverness of the people in this room, I probably have to print it out 10 or 15 times and then collate the results afterwards. And we'd have some, I imagine, robust conversations about what was the right way to do it. But that doesn't really matter, because what comes out of it is that we've discussed the system. We have a map, which we've all invested in, and to some degree, we're all moderately happy with it. We may think that it can be done better. We may know about components that are missing, and we probably will. And so what we've jointly done is built a better shared understanding of, in this case, electricity. How does it work? Maybe tomorrow I'll do magnets. And hopefully we have some kind of general benefit from that. Okay. You've already seen some shiny tools. They're not shiny. They're old-fashioned, but they still work. So the tools that I've been using in that example are all open source. It's GraphViz and XDot. So they've been around for yonks. The language that I was using there, which I'll just bring back up one more time in order to demonstrate what we've actually got. It's just a relationship of nodes to other nodes with a little arrow, and by doing that you get those two nodes and the arrow between them. The complexity of using GraphViz as a language to describe your maps can rise at whatever rate you like. Feel free to use, if you want to use GraphViz, use the repository code that I'm going to push up at the end of this to base your stuff on. There are other tools you can use as well. I find this works well because it's maps as code. I like things as code. They're easy to share, easy to regenerate into a variety of different systems. And there's some examples in here of what you can do to change the shape and color of the nodes. The GraphViz language itself is, well, let's just say that it evolved from the late 80s, early 90s, and is consequently as easy to use as you would expect when you get off into the weeds. But for just general day-to-day, I want a square here and a square there, and I want that one to be red, that one to be yellow, and a line between them. It's actually pretty straightforward. Let's make sure we save that. All right. Now, while I was working on that, you probably saw that the shape of the map changed every time I added a node or changed a dependency. So the implication of that is that if I've stuck this out, printed this out and stuck this on a wall somewhere and hung a pen next to it and asked people to update it, and then I've come back, captured the changes and printed a new version, it's going to be a totally different shape. GraphViz does not give you, without going seriously into the weeds, the capability to control precisely where those nodes are in the graph. And it's a graph, it's a directed graph in mathematical terms. You don't need to know maths to use it. It's actually a feature, that randomized layout, because although people might walk past it and go, oh, I know that map, I've seen that one before, you print it out, it's a different shape. The nodes are all in different places, and people go, oh, I hadn't seen that bit before. Maybe it had been there for the past 2 or 3 times, but they just hadn't noticed it because for whatever reason, it hadn't jumped out at them. There are many other tools that you could use for this sort of thing. There's OmniGraphal, there's Visio, there's various UML diagram makers, there's a whole variety of things. There's I don't want to name too many commercial things because I'm not spruiking any of them. But the thing I find is that it makes it hard to actually share those graph sources as code. And it's one of the things that I find valuable. What I've built at a number of organizations is continuous delivery for system maps. So a tool chain that goes from the source code repository into a build pipeline where that generation of the map happens automatically. And maybe it's merged with a couple of other maps, and maybe some other things happen as well. And it spits out an image which then gets hosted on a static website, which is displayed internally on the dashboard. So people come around to you and they go, that's wrong. You go, all right, let me just change it. Commit, push. 3 minutes later, the map on the dashboard has changed as well. So that fast feedback, that rapid cycle is relatively easy to achieve, and you don't kill quite so many trees. Okay. So some real world stories, some horror stories. Finding the people in the system. In one organisation, we used system mapping to discover, about 3 months before a key person went on maternity leave, that she was the only person who actually understood how the billing worked between two subsidiaries and the parent company through system mapping. And by asking people questions about what happened and who did what and which documents needed to flow and which systems were involved, we realised that there was a node in the graph that had a person's name on it. And so that node got a special colour, and the map got printed out and stuck up on the wall. And then within about a week of that happening, that person was being paired very aggressively with someone else who could take over when she went on maternity leave. A similar thing happened at another organisation with a payroll system, where people in the parent company had bought a payroll company, or the parent company had bought a payroll company, they were using it to pay their own employees, and if that person didn't log on to that system at that point and run that report, no one in the parent company got paid. No one knew that. So that was exciting. The systems that nearly got away. Systems that are old enough that people have effectively forgot that they're there. And it's only through the process of asking people who have been around for long enough, well, what does that talk to? What does that depend on? And they haven't thought about it for 5 years. You ask them the question, what does it do then? What does that depend on? Where does that data go? And they go, oh wait, there's that thing in the corner. We've forgotten about that. At a university, I went through a system mapping exercise, and we discovered that there was a system that they knew existed, it was on the network, but no one actually physically knew where it was. And it turned out that a couple of years previously, there had been some renovations. And the system was in a room that had actually, through a lack of communication, been turned into not a room at all. And it was small enough that you couldn't quite tell from inside this room or inside that room that there was another room there. The cable went into the wall and it came out the other side. And in the middle, humming away for 2 years, was a system. Everyone had forgotten about it. That was a good one. So that is the why we couldn't have nice things diagram, which some people might remember. Very shortly after that, it pretty much stopped getting updated. But these are the tricky bits. Because it's a manual process, because it's a physical process involving people and talking to people, it needs a committed curator. And that's part of why having people involved in its creation is important, because you can't just hand this off to someone. Someone has to choose to take it on and look after it and maintain it. You may get it to a point like that nice things map where you go, okay, that's enough, we actually don't need any more, and you can let it go stale. That's fine, maybe it served its purpose at that point. But if you are going to have to hand it over to someone, you want them to have been involved in it at least somewhat. It does take time. You've got to go and find people who understand what things are. You've got to get time in their calendars. You've got to get on their schedule. They've got to be willing to commit an hour or 2 hours every couple of weeks to actually talk to you about what they know. They've got to get into the flow and the rhythm of it, and to some degree they have to be convinced of the value. And it's very hard when you're starting out with nothing, with a blank page, to convince people of the value of this. So showing them some examples and demonstrations can help. It is a point-in-time snapshot. Because it's not automated, because it's not generated from live data, you do have to work at keeping it up to date. You could integrate this with automatically generated systems as well, and you could combine the automated bits and the manual bits through feats of extreme cleverness that I'm not going to do, if you want to, if that's what floats your boat. And in terms of GraphViz, the tooling is not incredibly user-friendly. It's good enough, I think, for me. It may not be good enough for other people, but it's the concept and the process that I think is more interesting and useful.